Well, look at the mailman delivered to me today. Another Harman Kardon. This is an HK 3270. I bought this on eBay. Got it for a decent price, very decent price, and it was for bids, and I was the only bidder. But it says it needed repair. It says left channel drops off after listening to it for a while. Okay, but I wasn't expecting this. This thing is like mint condition. Absolutely perfect. Clean, no scratches. Came with a remote. This remote looks like it's brand new. It's got hardly any wear on it. It's got like one little scratch on the back, and but you know, I'm pleased with this receiver. It's a nice unit. Getting it going will be nice. It says it was working. It's just the channel drops out. So we'll see what we can do with this. Let's look at the back. Freaking thing! It is huge and it weighs a ton. I'll tell you, I wasn't expecting it to be this big and this heavy. But here it is. AM/FM tuner, inputs for phono. These are blocked off because they don't want people using those for CD auxiliary tape monitor, tape 2, main input for the amp, preamp out, and we got outputs for subs. 2 sets of speakers, a few cat hairs. 2 courtesy outlets, and that's pretty much it. Built 11th month of 1999, so it's, you know, it's coming up on 21 years old. I think this is right around the area where Harman Kardon started getting into making AV amplifiers and stuff, and good 2-channel unit. So I'm going to open it up and let's actually just hook it up in first and see what it does. Alright, first power up. I got a standby light. Turn this on. This helps if I turn the speakers on. Compliments. Sounding good so far. Right now, we're Edmonton. Yeah, it seems to be all working fine. Join forces, trapping Edmonton in the middle forever. Come, the mute doesn't work. Should be muting the light's flashing. It says mute, but we're not muted, so maybe that's a problem. We'll look into the mute circuit. It's pretty simple. Everything looks good. Left channel? Right channel? I don't know what to tell you. Let's try some tones. No, that's not good. Did I hear a relay click? My distorted speakers. Yeah, that mute doesn't work. It's not having any effect. That's odd. AM. It's working. No antenna, of course.
Spectre de l'autisme. Ce qui est intéressant aussi, c'est qu'elle va raconter.
So what I'm going to do is just leave this on for maybe half an hour or so to see if the channel does cut out, and I'll come back to this in a bit. Well, I've had this thing on for the last hour, and it's done nothing out of the ordinary. So I don't know what I'm going to do about it. I guess shipping it across the continent probably shook it quite a bit. But if it had a bad solder joint or something, it's not showing itself now. I'm going to have to take a look inside and see just to make sure. Alright, so I'll open it up. Okay, let's have a look inside. It's a big unit, and there's a lot of empty space in here. But I expect what I'm looking for here is a cracked solder joint on a connector or a transistor, who knows. So let's power it up and see what we can get. If we can find the source of the intermittent power, intermittent sound. It's got it back on FM.
Visit cupboardsexpress.com. When news happens, Global News has you covered. The reopening has begun.
Our team of experienced reporters brings you Edmonton's most complete coverage.
CMP are here on scene investigating.
Stay informed with Edmonton's #1 local news. Global News Hour at 6.
I'm not seeing anything that's I'm touching that's gonna cause it to cut in and out.
Well, it starts with our furniture. It goes so much further. Our staff
So I'm gonna have to disassemble and have a good look. And the other thing is that maybe that previous owner experienced the problem of the left channel cutting out, but it wasn't with this receiver. Maybe it was with his speakers or his wiring, or who knows. Who knows what the story is. So I'll shut it down, take it apart. It's fairly simple. I have AM/FM tuner board here, and power amplifier here, and then this is all audio switching here, power supply, volume control, and front panel. There's really not much for interconnects or switches, besides the speaker switches, and I don't expect they will be intermittent.
Flex.
So right off the bat, I'm starting to see a little bit of the circuit glue that they used. Shut this off. You can see it around these big capacitors here. There's some circuit glue and there's some kind of corrosion going on. And I'll check out this board just to make sure it's clean of that stuff. There's some up here too. So I'll clean all that out, and I'll go over the boards with a magnifying glass, just check, make sure there's no cracked solder joints. Alright, so I'm starting to take this thing apart and go through it. It's pretty natural course of action going through one of these things. You're trying to hunt down a intermittent connection or something that's causing one channel to cut out. So I pulled out the tuner, and just out of normality, what I normally do when go through a receiver or amplifier or any piece of equipment is I'll go through one board at a time and I'll check each board out. And this is a tuner, pulled it out, and I checked all the connections here. This is a plug-in connector that plugs into the main board like this. So you got to remember, anytime you have an area where there's mechanical stress, you're going to have cracked solder joints, and there's no two ways about it. So this tuner is screwed to the back panel by 2 screws, and it's held there, and then it's also connected here at the board. So it's actually those only 2 spots. So if you have any mechanical stress between the back panel and the bottom panel, because this board is screwed down to the bottom panel, it's going to happen at these connectors. So you go through with a magnifying lens and you look at each one of these pins on both sides, and if you find anything, you just solder it back up. But I didn't find anything on this board. Another course of action that I do just because is I'll go through with an ESR meter and I'll check all these electrolytics, just because the board's out and I have the opportunity to do it. So I'm going to do it, and I didn't find anything there. Everything's good, 100%. The main board I removed because, again, it has the same thing. It has a back panel that all these connectors are screwed to, and it's fixed to the back panel. And then you have your board is fixed to the bottom panel, and between those 2 panels you're going to have mechanical stresses. And I check all of these connections for all these RCA inputs and the speaker, and I did find some. Where was it again? I didn't even solder it yet. I did find some on the one end here that were cracked. Yeah, there's one here. It's cracked. This is a phono input. And if you go through all of these and take a good look, you're bound to see 1 or 2 that might be cracked, especially on the ends where the most stress is. Capacitors, I ESR'd all these capacitors as well. A couple of these were getting a little high because there's a regulator here. There's a 67806. That's a 6-volt regulator here, and there's circuit glue here I pulled off. But these caps were borderline. I just decided to leave them for now. Circuit glue, I ran into some problems with circuit glue. There was some circuit glue here. There was some circuit glue down here that I removed. There's circuit glue here I'm going to have to deal with. I don't know if you can see this. There's a resistor here, and it's a 3.3 megohm, I think. I can't read it, but it was all coated with circuit glue. And this is a critical safety resistor because it is a connection between the line. If you look, this is all line voltage here, and then we have a resistor that goes across to everything else. And it's a 3.3 megohm resistor, and I think the purpose of these resistors is just to drain off any static buildup that might happen within these circuits, as opposed to the mains. Like if you have a potential difference of a few hundred volts, you can get an arc over on some components and it could do more damage. So what they do is they put a 3.3 megohm here just to bleed off any static buildup. I believe that's what it is. I'm not 100% sure. If anybody knows why they put the high impedance resistor across from the low voltage to the high voltage, let me know. But this thing's all coated with conductive glue, and what I'm going to do is I'm either going to replace this resistor or just try and chip it all off, because conductive glue, actually what I should have done is I should measure that. It's too late now because I already chipped it all off, but I'm going to measure it anyway. You can't read that, can you? Here. Try this instead. It's better? No, it's not. Okay. Let's see how my meter does with this resistor. Yeah, It's coming back at 3.3, 3.4. So either I got enough of that glue scraped off, or it wasn't an issue. So I'm just going to leave that alone. I'm not going to replace that. But that is a safety thing you have to keep in mind. Conductive glue. I had some conductive glue here on these two bridge jumpers, but these are all in the same potential. See, they're all in parallel, these 4 jumpers, so that was okay. I took it off anyways just because I don't want it shorting it with the capacitor. You basically don't want that glue bridging any conductors. That's what you don't want. So I'm going to resolder all of these, and then I'm done with this board, and then I'll move on to the power amplifier and in the front panel board. So I'll just quickly go through this. These break sometimes because you get a ham-fisted guy and he's plugging jacks in the back and he's unpulling them out, and there's a lot of mechanical stress on these RCA plugs. That's why I often see a lot of cracks around them too, and it's just because, you know, people plugging in, unplugging over the years, they pulling on it. Sometimes the jack's really tight, sometimes they're not. You get a really tight RCA jack and you're yanking on it. This is where it's going to crack first because there's mechanical stress, right? So I'll just go through and quickly make sure all these are 100%. And chances are a lot of these jacks have never been used. That's why they're not cracked. So usually the ones that do crack are the ones that are used the most, like your auxiliary or your phono. I'll do the speaker outputs as well. Okay, I think that's everything. I might have missed one here. And then I'll do the ones for the remotes. These ones, I don't know if you can see that, but you get a little bit of flexure. This one's really flexing. I'll just go through and touch these up. Okay, so that pretty much covers everything for this board. I'm done. I'm happy with the way I'm going to leave it. Like I said, I could have changed these few caps here, but I think they're okay. It's a 6-volt regulator. Everything's good there. I checked these. I pulled these out and checked them because I wanted to clean underneath them, and they were good. So I'm just going to put this board aside and work on the power amplifier now. So I removed the power amplifier from the receiver. It comes out as a module. It's got 2 screws on each side, and then just disconnect the wires and it pops right out. But I have a problem here. I can't access the underside of the board because it's folded over and screwed down, and the screws for all the transistors aren't accessible. So I can't remove the 6 screws and remove the transistors. without folding the board up, and I don't want to bend these pins. I don't want to flex these pins or put any stress on, because what can happen is you can pop one of the traces off the board because it's just held down with solder. So what I'm going to do is I'm just going to lift all these legs up, and then I'll so all you just heat the solder up and just lift the leg up. So I got the transistor leads desoldered, and pull off this temperature sensor, and then the board just lifts off, and then I don't have to muck around with heatsink grease or any of that BS. I can just leave everything alone, make sure that they're tight, and they got a good connection, thermal connection to the heatsink, and everything's 100%. Just put this aside. I don't have to worry about broken legs and lift traces. So here is the power amplifier, and I still haven't found the cause of why the original owner says one channel cuts out. Now, I still haven't found a cause why, but I'm still looking, and I'm hoping something on the power amplifier board will tell me what's going on with that. And I'm just checking all the transistors, and I'm not seeing anything that's really jumping out at me. Connections, transistors, that one's cracked. So this one here has a cracked leg. It's a driver transistor. They're all kind of just on the verge of, so maybe it's something that's just starting. Yeah, they're all kind of sketchy looking. Main power, I don't see anything there. Okay, so what I'll do is I'll solder up these 4 driver transistors, and I'll go through and ESR all these caps, and we'll see how it's doing. Okay, so I went over the board, and like I said, I only found a couple of questionable connections on these driver transistors, ones that have heat sinks. So I'm going to have to assume that's the cause of the problem with a channel cutting out. I'm not saying it is, but so far that's all I've found. I checked the capacitors too. I found something interesting. These capacitors checked fine, but these capacitors didn't. Now that's because the natural position for this board is sitting upright like this, and all the heat flows up. So all the heat from these is cooking these transistors, or these capacitors, and these ones are staying cool. And same with this side. These ones are getting cooked, and these ones are staying cool. So that explains that. So I'll go and I'll replace all of these capacitors on top here. Or sorry, yeah, capacitors, yeah, what I'm talking about. And I'll resolder the transistors, and then from there I'll just have to put it back together. And then after that I'll check out the front panel. I don't expect to find anything wrong with the front panel circuit board, but I'll look at it anyway since I got it all apart. And then we'll put this thing back in service. Alright, so I got the power amplifier recapped with audio grade, and then I went through and I resoldered transistors. It's pretty much all that I found on this, so it can be all put back together now. And I'll put this together, solder it up, install it in the cabinet, in the chassis, and then I'll turn my attention onto the front panel. I'm not expecting to find much there, but I'll have a look at it anyways just to make sure everything's 100%. So I'll keep plugging along. And I just wanted to mention that a lot of the capacitors I took out, they had high ESR. Not to the point where it would affect the performance or the operation. Well, it would probably affect the sound, but I'm not guessing it was high enough to, cause a channel to cut out like that. Usually when a capacitor causes an amplifier to fail, it's degraded to the point where it's not even a capacitor anymore. But these capacitors, they dropped about half in value, and they, doubled or tripled in ESR. So they were in there working still, but they needed to be changed because, I couldn't leave them in there much longer. They would not survive. Okay, so this is ready to go back in, and we'll pull apart the rest of it. Alright, I got everything assembled and back together, and I'm just going to test it one more time. One thing I forgot to address is the mute, and I'm just going to test it right now and make sure it's working. I got an auxiliary feeding it a tone, hooked up the speakers. And the mute button doesn't work. The light's blinking. It says mute, but I got no mute. Now, I've been poring over schematics on this. It's a pretty simple circuit. Let me try and explain it to you here. Okay. It's going to be hard to read. This LED here is the one that's in this knob, and the one that blinks when the mute is activated. So we know this part's working. This part's working, and it's coming from the front board. Get rid of that. On the front board, there's not much happening. There is a key matrix, which I don't understand because they have keys in here that don't belong to this receiver. So I'm guessing they use the same front board for many receivers, because it has video inputs, video 1, video 2, video 3, and so forth, right? But the mute button is off on its own, and it's on a little separate circuit board, and it comes in and it goes into the key matrix, and from here it goes into the microprocessor. So we know all of this is working because when we press the button, something in the microprocessor blinks that LED. So we know we're getting a connection between the button and the microprocessor to the LED, right? Also, on the microprocessor there's an output here, and it's marked front M, front_M, and that is the mute for the front panel button. And that line goes directly out to the main board. Okay? Now from the main board we have an input, which is F mute, and it goes in and it connects with 4 transistors. 4 transistors. These 2 transistors here, Q108 and Q107, are shunting transistors, and when they're turned on, they shunt to ground the preamp outputs. So somewhere between the microprocessor and these 2 transistors, you have a disconnect. So let's try and see if I can figure out. I got the transistors located here on the board. And what I want to do is I want to take a voltmeter, and while the unit's running and I mute it, let's just see what happens here. So turn this back on. Ah, here's another problem. Did Did you hear that? As soon as I turned it on, there's a big thump out of the speakers and there's no power on muting. That's another problem, because right beside the front mute there's the power on mute, and it's a different circuit. So what I'm going to have to do is figure out what's going on with these two. Anyways, let's try this first to see if we have anything. Find a ground. And we need Q 108. 108 is that one, okay. So let's see what we have happening here. What do we got there? Seems like it's just floating. This must be the collector. Nothing. Nothing. I don't think we have any voltage to the circuit. Let's try the other transistor. Expect they're both the same. We're getting nothing out of the nothing. So we got to figure out why the protection circuit isn't working. Okay, here's a schematic of the power amplifier. If you look here, we got the mute circuit here down the bottom. Let me get a pen. Where's my pen? Okay, so this mute signal comes from the main board. It's called power mute. You can see that. And then from here it goes down and it goes into this transistor. And this transistor switches, and then it turns both channels off, and it's got a time delay 3.5 seconds. 3.5 seconds from turn on, and then it turns the channel on. So this is the power mute that's not working when I turn the receiver on. Now it comes from the main board. Let's have a look at the main board. Here's the main board. And here's that power mute line from the amplifier. And all it does is it goes straight through to the front board. And it's got the power mute there. So the F mute and the power mute are not working. And same with this. If I got front mute and power mute. I know it's hard to read, these schematics are terrible. Coming from the main board, and this is the front board, and it goes straight into the chip. pin 26 and pin 24. So let's scope, but let's look at those levels of those two. Let's see if they're working or not. What I'm going to have to do is I'm going to have to flip this up on its front and keep it running. So let me just pause the camera for a sec here. Okay, I got it sitting on its front panel. A little tricky, but you have to raise it off all the buttons. So what I want to do now is I want to get in here, and I want to check these lines 24 and 26 on the main CPU to see if they're going high and low when I activate the buttons. So first is 24. This is going to be difficult because these pins are small. So I've got my voltmeter running, okay. Let's see if I can get in there. I can't even see hardly. Short anything out. Okay. I'm at a 5 volt. I'm going to hit the mute button if I can find it. Where is it? Didn't change. And that was the power mute. So let's try shutting it off. And we'll see if it has a 3.5 second delay. Goes down to 0. Turn it on. It's at 0. Then it goes up. So that's working. That's interesting. Okay. Now let's hit pin 26. There. Yeah, I got 5.17 volts. Hit the mute button. It dropped to 0. Hit it again. Back up. So that's working. The line out from the microprocessor is actually working, but the signal's not getting to the rest of the board. So I'm thinking maybe I got a problem with this cable or something else that's going on. So I'm going to have to do some more investigation. Alright. So now I know the CPU is outputting the proper signals to the receiver. The receiver is not getting them though. I'm going to check this ribbon cable here. There's a couple marks on the board here. One is power mute and the other is T mute. So what I'm going to do is go on T mute. Let's see here. 1, 2, 3, 4. Yeah, this is going to be one, 2, 3, 4. That should be the mute button. If I hit that, I'm getting no reaction. Oh, hang on. Okay, let's try the other one. Power on mute. This thing wants to fall over. I can't figure out which pin is which here, so I'm going to have to take it apart. So I'm just going to run some continuity tests here on this board. From the pin 24 and 26, it should be a straight shot out this cable. We'll see if it's happening. I don't think it is. I don't know why it isn't. Maybe it's unplugged in there, but we'll see what we can do here. Pin 24 is that one, and if I follow pin 24 from there, I should be able to find out exactly where that pin. Go cross-eyed looking at these traces. They're only half a millimeter or so apart from each other. So let's try this again. And not, if I stab this trace, it's working okay. Just keep going. Okay. I'm just scraping off the solder mask as I go, just so I don't lose my place. And then I know, right there, it's connected. Okay, so that's third from the end. Third from the end. Let's see what we got here. I have a feeling this cable's bad. So that goes that way. So that would be third from this end. Third. Got nothing. Let's check some of these other ones. Let's try the last pin. The last pin. Nothing. Oh, I got it backwards. Okay. So from here to here, that's working. From here to here, that's working. From here to here, it's working. So from this chip to this pin, it's working. Okay. Let's try the other one. 26. 26. Oh wow. Front mute. Okay. Second from the end. Second from the end. There. Everything's working on this board and this cable. So the problem lies on the main board. We don't know why it's not getting out. The signal's not getting out there. Put it back together and we'll troubleshoot from the other end. Okay, so we're back together one more time, and I'm going to check continuity, or for presence of a signal on the main board. If I can get my probe in here. That should be, and I do have 5 volts there. Let's hit the mute. It's gone to 0. So the signal is getting to the main board. We gotta pull that main board out and figure out why it isn't working. One more time, pull the board out. Alright, I think I'm making some progress here. I was going through the what really threw me off was the schematic is wrong. And I'll show you if I can find the papers. Right here. It shows this, let me get this in frame here for you. F mute line comes up and it shows it connecting to the base of this transistor, base of this transistor, and base of this transistor. But in reality, this line goes right past these two and connects with this transistor only. And that's what I couldn't figure out in this circuit. I checked all these transistors, they're good. I checked the 33K resistors, they're good. I went back here. This line here is fed through two 560 ohm resistors. See, there's two 5 560 ohm resistor. I don't know why they put 2 in. They could have just put a 1K in there. But this goes back to the plus 48 volt line, the B plus. And then this is a common star ground. There's a capacitor here, and then this feeds current or voltage into the circuit to supply it to work. Now I couldn't figure out why I wasn't getting any voltages around here, so I started checking, and then this 12K resistor is open. So what I'm going to do is I'm going to replace this 12K resistor. That's R182, and that should bring this circuit back to life. But I'm still concerned about the power on mute, the 3.5 second delay when you switch the amp on. I can't figure out why this circuit's not working. All these components I tested are good. There's only, I'll have to check and make sure the signal's getting to this board. I haven't done that yet. And then I checked these 2 steering diodes here, they're good. 33K resistors, they're good. I checked the front end transistors, they're good. So I'm going to go and replace this 12K resistor with a new one. And then I'm going to reassemble. And then I'm going to test it out one more time, see if we can make any progress. Okay, so assembled it, connected it up so we can test it. Let's power this thing up. We're on auxiliary. Let's feed it a signal. Mute. Perfect. It's working. Now, the other thing is, we still see if we have our 3.5 second delay on power on. Perfect. It's working. So that one resistor influences both those circuits. I don't understand why. They're not related in any way. But we're done. It's a wrap. Alright, let's curious on what this thing puts out for power. It's got a big lump of iron back here. Let's hook up a dummy load and see what it does. In case any of you are wondering, here's date code. 21 years old. Still relatively young piece of equipment. The funny thing about this amplifier is there's no adjustment for the DC offset. So I just want to check I got it on speaker B right now. And I never did hear any thumps on the speakers other than when the mute wasn't working. So what do I got here? 10 millivolts on the right channel. And I got 54, 53 on the left, which is acceptable. It's not like the amplifier's out of whack, but there's no adjustments. So, all right, let's put a signal into this thing, and I'll get the scope hooked up, and then we'll see what it can do. Okay, so we got it all wired in with the load, and we're feeding it a signal. Let's turn up the volume. Where's my glasses? Let's see. I have to crank this thing up. Wow, it just keeps going. There we go, hit clipping. Okay, so we got a good look at what's clipping here. Right there. 23.8 volts RMS. I thought I would have been doing better than that. I thought it would be a little more powerful, but that's not too bad. Let's see. Yeah, it's clipping right there. Let that cook for a while and see how hot the amp gets. It's got a huge heatsink on it. Big aluminum plate, and then it's got all these fins. Nice spacious design too. Like there's all kinds of room for air circulation inside here, and I think it's it's built to do the business. Funny thing about this is I didn't realize it until after I had it all in pieces. Is it's got provisions for a remote, and I didn't get the remote with it, which is unfortunate. But oh well. Yeah, it's barely getting warm. Running at full power here. Let that cook for 10 minutes or so. Another thing I noticed about this receiver is that the pots are all nice and clean. The treble control, the bass. Balance. And the volume is a motor driven pot. That's a well built unit. Okay, it's been on for about 7 minutes now, full power. This is starting to get a little warm. This dummy load though is scorching. Yeah, that's quite a bit of heat there. Okay, I'm going to shut this down. I think we're done. I've seen enough and I'm happy with it. So we'll turn this off, and we're going to wrap this up here. So a little where is that thing? I lost my resistor. Little tiny resistor, 12K. Defeated the mute circuit, so replaced that and we got that going. Replaced some dodgy caps in the power amplifier that needed it. I know people will say that you don't go in and replace caps that haven't failed, but they were failing, and even though the amplifier was still working and fine with them in there, I think it's probably an improvement replacing those failed caps. And the little bit of cost it cost, I don't know, maybe we're talking 20 cents a piece. We're talking maybe $2 here, maybe $2 extra on repair. That might seem a lot of money to some people, but I think it's important to get the garbage caps out of the equipment. But some people will complain that that's not right, but whatever. Okay, I'm going to wrap it up there. Thanks for watching, and we'll see you on the next one. Got more stuff to work on.